All right, so what we're going to do is we're just going to jump into chapter 8, and we're going to pretty much fly through the homework together. So kind of like what we would do in class, feel free to take notes as we go through these as though these were like lecture notes. And I'll also have what I've written down posted online, but of course it won't really make much sense unless you're watching the video as well. What I'm also going to do is I'm going to skip over some of the like introductory stuff, those like prep questions. I'll let you figure those out and see why they're true, or press to help me solve this. We're going to jump into just the doing the math questions. Okay, so what are the square roots of 81? Well, you've got a square root button on your calculator, but the question is what times what, or what times itself will give you 81, and the answer is 9, or negative 9. Because remember, if you multiply 9 by itself, you do get 9. Oops, we were doing stats. 9 times 9 is 9, and negative 9 times negative 9 is 81. The one thing I want to point out to you, be really, really careful about this, is that your calculator is correct. And what I mean by that is if you type negative 9 squared, your calculator is not going to multiply that negative 9 to itself twice. When you write it like that, here's what you're actually writing. You're saying, I want a negative of whatever 9 squared is. That's what you really typed in, and you just don't know it. So how do you do this correctly? Well, you say, I want negative 9 to be multiplied to itself twice. There we go. All right, so just be careful about that important distinction about how your calculator is going to work. Also, remember that kind of what goes on here is we... Interesting, I got the same question twice. I guess the randomization was just kind of off. Also, just remember that when you square root something, like 81, if you did this backwards, if you didn't know what it was in your head, or if we get to some larger ones later, it's only going to spit out 9, and we refer to that as the principal root, or the positive root. But there are two solutions. It's either positive 9 or negative 9, but the calculator is only going to spit out the what we call principal root, so just be careful. I guess I'll skip that one since it was a repeat. If the index is even, what is the principal root of the number? We just kind of talked about it, the non-negative root. Okay, moving on. And I guess I said we were going to skip those prep questions. So what's the principal root of 100? Again, it's what the calculator would spit out, just 10. But it could be plus or minus 10. What about this one? Well, guess what? You cannot square root a number because, let's kind of write it down like this. If I multiply, and I guess maybe we think it's 6. If I multiply 6 to itself, I get 36. If I multiply negative 6 to itself, I get positive 36. So how can I multiply something to itself and get a negative, or how can I square root something that is negative? Well, guess what? You can't, quote unquote. Or in other words, you get a non-real answer. So the square root is not a real number. So that's kind of an important thing to say because this is not saying that there is no solution. Maybe you know that there's some way we can turn this into some sort of answer, but the question is find the square root that is a real number. And the calculator says that we get a non-real answer. So in other words, there is an answer. You can square root a negative, but it's not going to be real. And we'll investigate that later in chapter 8. All right, this one, notice the negative's on the outside. So in other words, hey, square root 1 and then put a negative after whatever you get. Well, the square root of 1 is 1, so put a negative after I get the square root. Let's see maybe a more complex version of that. Hey, there's a more complex version. So how do you square root fractions? Well, the way you square root fractions is you just square root each part of a fraction. Or in other words, here's an important property of square roots. If you have a fraction, or if you're doing multiplication, then you can write this as, well, the negative still tags along outside, but the square root of 64 over the square root of 25. And that's kind of what I said. You can square root each part of the fraction, the numerator and denominator, and then just keep them in their respective places, the numerator and denominator. Well, 64 roots to 8, 25 roots to 5, the negative was outside, so it's just been tagging along the whole time. So there we go, negative 8 over 5. All right, then we get to cube roots. It's definitely good that you have a calculator in this class, but a cube root is saying what times what times what multiplied to itself, or what number multiplied to itself 3 times will be 64. And we're just going to rely on the calculator for this. Or, what we do in some classes is we start kind of writing out, perfect squares and perfect cubes. So we would say 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. And then maybe we would say 1 cubed is 1. 2 cubed is actually 8 if you multiply 2 to itself 3 times. 3 cubed is 27. And actually, hey, guess what? 4 cubed, it is indeed 64. So the worst thing you could do, so to speak, is just make a list of a bunch of perfect cubes until you see your number. So it must be 4. But we'll see how to do this on the calculator in a second. All right. We also get something interesting here. We have a negative this time, and you might think, based on what happened a little bit earlier, that, hey, if you square root a negative, you get an error. What happens when you cube root a negative? Well, it turns out you don't get an error. Because if you're performing 3 multiplications with a negative, you can actually get a negative. So let's see what this is. Let's find the cube root button. We can go to Math, if you click the Math key, and there it is, number 4. I actually prefer number 5. Number 5 says you can insert whatever root you want, and that's probably going to happen later. It might be a 3, it might be a 5, it might be a 7. Let's just use, again, Math x root to say, I don't know if it's going to be a cube root, but I can make that root whatever I need it to be later. So cube root of negative 729 spits out negative 9. Interesting. Negative 9. So this time, with odd roots, you can get negative answers. And let's just show why. Because negative 9 times negative 9 times negative 9. Maybe now you see why a negative is possible, because 3 negatives multiplying will be negative, and 9 times 9 times 9 is 729. So really, Chapter 8 so far is saying pretty much, hey, rely on your calculator. All right, more general, we can start to generalize some rules here. If I have an even root, then I can't even root a negative for reasons we discussed before. Something multiplied to itself 4 times is going to have to be positive. All right, this time the negative's on the outside, so I can't perform that. And again, I can type that in exactly as I need to. Math nth root, or whoops, I guess I need, how am I going to write this? I know what I'm going to do. Oops. I'm going to 4th root 256, and I'll just make that negative afterwards because I know the negative's out front. All right, and we're moving right along. So this time we're going to cube root negative 125. Now I do get negative 5, but I haven't taken into account the negative out front, so in other words, there is also a negative 1 times whatever my cube root was, so it's positive 5. So the cube root of negative 125 is negative 5, but there's also an extra negative out front, which turns it out to be positive in the end. All right, and now dealing with cube rooting, well, there is a negative inside, and that's okay with odd roots. There will just be a negative out front. And depending on your knowledge, well, we've kind of seen that if I cube root 64, that's 4, that came up earlier. And it turns out if you cube root 343, you're going to get 7. All right, now the other thing is your calculator can do this again. If I do the cube root of negative 64 divided by 343, it does give me that ugly decimal, but of course I could press math fraction, and there we go, negative 4 over 7. All right, up next, this is a little bit of an interesting one. When you try to square something that's being squared, its answer is absolute value x instead of just regular x. And why is that? It's because when the index or the power of a, or sorry, what's here? The expression square root of x squared means the non-negative square root of x squared, even if x is negative. It feels like it's going to be C or B. Let's see here. Aw, see? Those ones I don't really care about too much, you know? But let's just do it again. Oh my gosh, I just did the same thing twice. What the heck am I doing? Alright, whatever. Alright, so the thing is we are going to have to worry about that rule. We're not necessarily going to worry about why. But really what that rule is saying is that because we're squaring this first, we know this is going to be positive. So then when I square root it after, I should still get a positive answer. So that's the idea. Square rooting needs to have a positive inside. X squaring will produce a positive. So even when these two cancel out, technically I need to take the positive of what cancels out. So let's see here. 81 roots to 9. And when I square a square root, what's going on there? Well, again, you're getting some cancellation, but that cancellation needs to live inside an absolute value. I think I can get away with writing it like that, or I'm just going to use that absolute value symbol. And, you know, I just can't live with that red X. All right, let's just try it again and get the answer right. There we go. All right, and we'll continue from there. This one, again, same idea. When you square something that's being squared, technically you need to make sure you get the positive outcome of that, because squaring it will turn it positive, rooting it needs to output a positive. So even though there's cancellation, this thing needs to become positive. All right, now same idea, only this time, let's see here. I'm going to write it like this, but I'm not going to stop here. The idea is I'm going to have x plus 6 to the 6th. Now, how do I know that? Well, let's get into some notation here. When you have, for instance, a square root, and that is what a square root is. It's actually a root with a 2 there, but the 2 is implied when we don't see it. So when you have a square root of, I don't know, 81, it turns out that that's equivalent to 81 to the 1/2 power. And let me just prove that in the calculator. So I can type 81 to the 1/2 power, and look, I get the same thing as square rooting 81. Now, what that does for us is it lets us write the problem we just had like this. It's x plus 5 to the 12th to the 1/2 power. So what happens there? Well, when you have an exponent to an exponent, you get multiplication. And when you multiply a whole number to a fraction, or a fraction less than 1, you're really performing division. And so that's where the 6 is coming from. 12 times 1/2, or 1/2 of 12, is 6. Now the other thing is, again, we need to force that to be positive, and that's why it's an absolute value. Only wait, let's think a little bit further, because if this is still to the 6th power, this was kind of an interesting idea, if it's still to the 6th power, then, well, anything to an even power is going to become positive anyways. So in this case, again, when you square root something to an even power, you should have absolute values to force it positive, but the 6th, the even power left over, because there's still some extra exponents, so to speak, that even exponent left over is going to make this positive anyways. So in this case, the absolute value becomes redundant. We don't need it, so we can get away with writing x plus 5 to the 6th power, because that 6th power is going to force the positivity. I don't need absolute values. All right, same idea. This one's actually a little bit simpler. We get x to the 6th. All right. Also, we get some interesting wording here. It says, assume that all expressions under the radical represent non-negative numbers. Now, what is that extra wording saying? That extra wording is saying you don't need absolute values because we already aren't dealing with any negative numbers. So in other words, I don't need to worry about putting absolute values in front anymore. Cool. And just in case you're wondering, on our exams, we are going to always assume that we're dealing with non-negative numbers. In other words, I'm not going to make you worry about do we need absolute values around this or not. Deal with it in your homework. It does matter for your homework, but on exams, know that we're always going to use this wording so that the absolute values become unnecessary. So, and again, here's what's going on here. 36 does square root to 6, and 18 to the 1/2, an exponent of 18 to the 1/2 will take 18 times 1/2, so that's where I get the 9 from. Same thing, 38 cut in half because of 38 to the 1/2 will become 19. All right. Again, we have non-negative answers, so absolute values are unnecessary. This time it's an odd root anyways, though, so absolute values wouldn't have been needed anyways. It's only in those even root situations. All right, same thing here, only this time we're dealing with division. So let's write down this rule more generally, this rule that we kind of saw earlier. The general rule here is that if you have the nth root of a to the m, then you really have a to the m divided by n. Again, the reason for that is because you really have a to the m times 1, or to the power of 1 over n, and those end up multiplying together. So the idea is what this problem is saying is, hey, you've got x to the 18 over 6 power, but 18 over 6 simplifies to be just cubed. All right, find the indicated value of the function. Well, we can plug numbers in. That's going to be 8 plus 8, which is 16, which roots to 4. And I've gone a little bit over. Let's just see here. YouTube only lets me write down 15 minutes at a time. All right, the last thing we need to do here is worry about square root domains. And the domain of a square root, I'm going to write it like this, is anywhere that function on the interior of the root. So if you've got some function on the interior of your root, you need to make sure that that's greater than or equal to 0, because we can only square root or even root positives or 0. And so what happens here is you end up saying, well, then 2x plus 7 needs to be greater than or equal to 0, which means we can subtract the 7 and divide the 2, and we get our domain of anywhere that x is greater than or equal to -7/2. All right, and then you've got one more question and we're done, and I think you can do that yourself. Make sure that you type it in interval notation that time though.